Okay, final one. Number 4, more chops. Just kind of diving into just more ways you can use chops. The first videos I really just showed LFO and noise, but the whole chops family is so many like really beautiful ways that you can just shape data, shape kind of like control voltage to do all kinds of different things. So what I want you to do is look through these, especially these 10 chops on your own through the operator snippets. If you go up to help, so let's say if you like select, let's say join, go up to help, operator snippets, and then we see some cool examples. So this one only has the one, but there are so many cool examples like trigger chop, for instance. There's like 7 different examples for how you might actually use that. So I want you to go through for these specific chops, look through all the snippets, just kind of play with the examples a little bit on your own. And then for now, I'm just going to talk about lag, filter, and delay, which I have right here. Um, so this is kind of looking at, let's pause that for a second. So I've got a noise chop here. And so these are basically ways that we're softening the contours of channel data or filtering it in some other way. Um, so right now I'm looking at lag, right? So I've got noise coming in. I named the channel noise here, noise, beautiful. And then it's going through a lag chop with a couple seconds of lag on both going up and also coming down. Renamed it to lag, going through a switcher. So I'm selecting one of these 3, the lag, filter, or delay. So right now I'm selecting the lag. Coming back into a merge, so noise and lag come back together. And then to a trail again, so window length is 4 seconds, so we're seeing 4 seconds worth of those. So the red line is the original noise, the yellow would be the lag, and you can kind of just see what exactly you're doing with that. So the brief peaks and valleys get smoothed out a little bit, and it just kind of changes that data. One other thing that we haven't addressed directly maybe is the idea of time slicing. So you see right here, this has 600 samples. Because by default, on channel here, it starts 0 to 10. And we have 60 frames per second. Therefore, it creates 600 samples. But then when it goes into these operators, it goes down to a single sample. And also, it's kind of weird. So this appears static, right? But I can see, like, okay, so let me just go ahead and see. I can see time slice here, maybe. Right there. So what a time slice is, it's a kind of like usually one little sample. Sometimes it could be more than one sample, depending on if your CPU can't really process everything at once. So samples get kind of like backed up, maybe. So what it's actually doing right now, it's not really apparent as these frames kind of go through here. It's actually scrubbing through samples 0 to 600, or 0 to 599, I should say. So there's kind of this loop of 10 seconds of 600 frames, which correspond to a loop of 600 samples here. So we're kind of seeing this noise loop like that. If I did something like that, so we only see 300 samples, look what happens. So as it loops, it kind of goes and then it kind of just stops. So it does half of it and then stops for the other half. So hold, we could do something like mirror, in which case it will keep looping. So these are little things that you can play with. So what if I only did, let's say, like 9 samples of noise, and I've got it mirrored. So now it's just kind of like looping through that over and over and over again. sometimes that could be helpful, right? So this is like, it's kind of hurting my eyes a little bit. So this is, it's random, but then when it's looping over and over, it becomes a kind of periodic pattern. It gets its own kind of rhythm to it, so that could be cool sometimes. But just something that I wanted you to be aware of. I think that's fine for now. So it's just looping through these 600 samples. So we can see what lag is doing there. And I touched on this a little bit before, but something like overshoot. Right, then that looks really different actually, right? So now so when it's going up, it's lagging for 0.1 second, and then it's kind of overshooting a little bit. And we can kind of see when it's going up. Actually, the overshoot seems to happen more on the down, right? Let's do 0 on that. Let's do like 0.3. There we go. So that looks very different. Yeah, it's kind of going beyond, and then it tries to catch up after that. So, I mean, so many different variations. You can, just shape the data in different ways. Make that really tiny. Cool. Okay. So, lots of ways you could play with that. One thing I might use with lag sometimes, I only want, data to kind of lag in one direction. So in this case, when we're going up, it's not really following the input, but when it's going down, there's no lag at all. So it kind of follows it perfectly. So just lots of different ways you can create those different contours. Great. So let's look at filter. So by default, filter set to 1 second. So this is like super smoothed out, right? There's really no peaks or valleys anymore at all. Let's do 0.1 second instead. There we go. So filter tends to really smooth it out more. So it's really just, what it's doing is filter width to 0.1 second. So it's taking 0.1 seconds worth of samples from the noise, and it's basically averaging them, and then taking the next little block. So it's kind of like averaging all those little filters, all those samples. And change effect. Right, so if effect is 0, it essentially is like a delay, where you can see it's not actually shaping that at all, but it is still kind of delaying it by 0.1 second. So that could be interesting. Different types. I mean, you can play around with all these also, like just so many variations. So this kind of creates a nice, if you need the data to be a little smoother. Like for Arduino, this matters a lot. A lot of times with like a FSR sensor, you're kind of hitting it, but the data is really, really jittery. So common thing, you just put in a filter, maybe do a filter width of something like ½ a second, and then that's going to smooth it out a whole lot more. Especially if you want to use that, let's say if you're using FSR to control a level top somewhere, and it's making the kind of like a jittery strobe light type of effect, and that's maybe a little bit too annoying, filter will just kind of smooth that out a little bit. And then finally the delay here, kind of what I just did with the filter in a sense, but delays, let's say 1 second, let's do like ½ a second. All right, we can see the peaks here. So the actual data is not being shaped differently or smoothed out at all. It's simply being delayed. So that could come in handy in any one of different ways, like audio visual effects that are triggered at slightly different times. Could be really useful. The reason why there's a delay and then a max delay, sometimes, like if it can't, maybe it's doing some other processing, and it can't actually output this at exactly 0.5 seconds. It like waits like a couple frames before it can output it. There you can set this so like it absolutely won't go beyond this, let's say. Also, usually max delay could be different if let's say you have like an LFO or something that's changing this delay. This can actually be kind of cool. Let's see what this does. LFO, and I'm going to make this amplitude offset. So I'm going to change this delay time. And usually it just doesn't really matter if max delay is just a little bit, just some value that's higher than what this is going to be. It just gives you little security. I typically just kind of have them basically the same value, but whatever. So you can kind of see delay is changing a little bit there. That's kind of cool. Okay, cool. So those are a few other ways to kind of shape your data. And then once you look at all the snippets for these, I think you should have a little better idea for creating data structures and shaping data in more interesting ways. Okay, cool.